Okay, welcome back. We are busy with assignment 3 and we are on question number 15, the last question of the assignment. It was a 20-mark question, and together with the previous question, which counted for the question 12, which counted 15, it was the two questions that had its highest weighting towards the overall assignment. Question 15 reads that your client is interested in purchasing a fully developed business property. A 30-year lease has been registered against the property, and the net rentals payable in advance are as follows. So we had a structure of the first 5 years, then the second 5 years, and then the next 10 years and the next 10 years. It's a 30-year lease. So let me just again outline that on the board. To show you the pertinent points. The first 5 years payable in advance was an annual rate of 400,000 per year. Then for the second 5 years, from year 6 to year 10, that went up to 500,000 per year. That period. Then from year 11 to year 20, it started off at 625,000, but it escalated at 6%, and then that was from 11 to 20. From 21 to 30, it was 1,200,000. And there was an escalation here of 7% per annum. The interest rate, or the cost of capital rate, or the opportunity rate, whatever you want to call it, was 11.5%. That's just your outline, and you are needing to determine the amount which your client can pay for the property. If he requires 11.5% of the per annum on his investment. So in essence, you are going to be working out the NPV, doing a cash flow analysis. It basically tests your ability to discount cash flows, DCFs. Okay. The first year 1 to year 1 to 5, there was no escalation There was no escalation. So you would treat that as a present value of an annuity, present value of 1 per period, as we learned in year 1, first year. They are annual payments. So we have to set your calculator to 1 per year. We say year 1 to year 5, it's 400,000 plus minus, and that's per year, so it's a payment. It's not a present value or a future value, it's an annual payment, so it's input as a payment. The term was 5 shift N. Your interest rate is 11.5, nominal percentage, and you are told they are payable in advance, so you need to set your calculator to begin. and then you determine what is the present value of that. Step 1, present value is 1,627,845.52. 1,627,845.52. $400,000 plus minus payment. 5 shift N, 11.5 shift nominal percentage. Set your calculator to begin. PV 1,627,845.52. One per year, Lloyd? Okay.
PV
Yes?
1,627,845.
All right. Now write that figure now somewhere down, because that's going to be, when you require that to work out your final answer. Now your second term is from year 6 to year 10. It's a similar question, similar calculation rather, where you have a payment of 500,000 plus minus, that's your payment. It's also for a 5-year term, and at 11.5%. Your present value of that is 2,034,806.90. 500,000 plus minus payment, 5 shift N, 11.5 shift. So I'm going to write some of these numbers on the board just so we can keep a record of it. We already had a figure here, let's call it the 1, of 1,627. $845. Now, when we discounted that figure of 500,000, I got a figure here of 2034.
2,034,806.
2034.
806.
Yeah.
0.89.
But now remember we've discounted that 500,000 for that period, and we are over here now, at the beginning of the 6th year. We need to further discount that to get to the same point in time as that value. So now we need to take that figure of 2,034,000 as a future value. Shift and clear all. 2,034,806.89 plus minus future value. 5 years at 11.5, and we get 11. Is it 1180? Yes. Why is it doubt?
1180.75.
So it's the second figure we require is going to be 1,180,000. 725, comma, if you want to work with cents, 28. Is that your figure? Right. So we've discounted the two rentals, cash flows that were not, cash streams that were not escalating. From there to there, the 400,000, we go to that. And after taking the 500,000 first to there, and then furthermore to there, we go to that figure. Here we are dealing with a rental, escalating rental. So we now have to go and revisit the cash flow function, CFJ function. It's 10 years, and that's 10 years. So let's take the first one. Forget about the begin and end, because that doesn't apply anymore.
No, it's really clear, not clear.
Clear. It's completely different.
Beginning.
No, you don't want the beginning. You want it off. Eh? So now you want the 11.5% as your interest rate, and we're saying for 10 years. So we're going to go up to CF9 because it's upfront, payable upfront. So the first 625,000 is CF0. And we're going to add, afterwards, we're going to add 6% until we get to CF9. Can you do that?
CF9, it's not, was it the end of the period?
Payments are up front.
Oh.
Payments are up front. 625,000. CFJ. Plus 6% CFJ, plus 6% CFJ. Keep on adding the plus 6% and then CFJ until you get to CF9. You say shift in NPV, and I get a figure of 5030, which I'll double check now. $5030.299. 46. But that figure is over here. I'm just adding the 6. I'm just checking that number again. I somehow think it is right. $5030.299.46. But that is now at 0.10 at the 10th year. You have discounted it from 11 to 20 from the beginning of 11. You've discounted that series of that cash flow back there. So you've got that figure at that point in time, which you now have to discount further by 10 years as a lump sum. So you take 5030, 299.46 plus minus future value, 10 years, shift in at 11.5% interest. Your present value of that is 1693. $1693, 733.85. So that is your discounted value of that cash flow at all the way back to 0.0 on the timeline. 10.
No. How many years?
Sorry, did I take it? It's 10 years. It's from there because from here, this is at this point in time. You've got 10 years back.
Yeah, to 0.
To 0. This one will be, the next one will be 20 after we've done that. So the next one will be between 21 and 30. You're starting off with 1 million. First of all, key in your interest rate of 11.5. 1,200,000, which is CFJ, 0, and then 7% plus 7% escalation. Until you get to CF9. And your NPV will be 10,039, if I'm correct. I will double check that in a sec. 389.15. We started off with 1,200,000 CFJ plus 7%. $10,039,389.15. But that is now exists here at 0.20. And we need to discount that further by 20 years to get to the end, to the point 0 on the timeline. So 10,039,389.15 plus minus future value 20 shift in at 11.5. My present value of that is 1138, which is the figure I need here for Paul. 1138. $177.36. Okay. Now to get to the net present value of all of those, we need to take 1, 2, 3, and 4 and add them all up. One 693 733.85 plus finally 1138 177.36, and your grand total, which correct, 5,640,000. $482. Someone's happy. You can leave the cents out and you get to 5,640,482. Now, to get your marks for that question, I would have broken it down and structured it so that I'll give you, I think if you get asked that question in an assessment, you'd be asked to write down each answer separately before adding them up together. So I could find areas to give you marks as opposed to giving you all or nothing. It's a lot of marks to lose in a paper. So that in essence is the net present value of that cash flow, of those 4 cash flows. But it entailed no fewer than, I think, 6 or 7 calculations. 1, 2, 3, 4, 5, 6, 7 calculations. 7 calculations, and then finally adding up the 4 answers to get to your net present value. To do a discounted cash flow. It's typical of a valuation when you are discounting a long-term lease. A long-term lease. Okay, that takes care of the last question of that assignment. What I would like to do next is to just illustrate for you further calculation based on portfolios, portfolio returns, as well as on the probability of outcomes, which is what we would have done towards the end of the towards the end of the course. A portfolio is obviously comprising of 7 different properties. And I'm going to give you an example now where this investor has got a portfolio with 2 properties in it. You would possibly get a question like, I'm just going to write down this question, then I'll talk through it. Let's assume portfolio A represents 30% of his portfolio. And portfolio B represents 70% of his portfolio. There are 1, 2, 3, 4, 5, 6 years cash flows if forecasted. Not cash flows, your expected returns, your expected rate of returns for each one. Given this is information that's given, I will ask you to do something with it just now. 16%, you get 16% in the expected 16% return, expected 15% return for 2019, expected 17% return, 16. Expected returns on this properties as an investment for the year. For property B, the expectations are as follows. So you're given a scenario with an investment, 2 properties. They must collectively add up to 100%, obviously. That's his 100% portfolio. This property comprises 30% of his portfolio. that property comprises 70% of his portfolio. This is his expected returns per annum for these respective years. And that's his expected return for that property per annum for the same period. Now the question would be, calculate the expected portfolio return percentage for each of the 6 years. Expected portfolio return for the whole portfolio. So how would you calculate the expected return for the whole portfolio per year? You would take its expected return for that property times 0.3, which is the 30%, and that gives you 4.8. And you'd multiply all these by the 0.3. And that will give you 4.5, give you 5.1, 4.8, 5.1, and 5.7. That's its contribution towards the portfolio return. It's percentage. You do the same with property B, but you'd multiply this with 0.7, and if you multiply that by 0.7, you get 12.6 times 0.7 equals 12.6. 11.9, 11.2, or is this 10.2? I think this is 10.2. 16% times 0.7, 16 times 0.7 is 11.2, that's correct.
10.5.
That's it, Lloyd, thank you. 10.5.
9.10.
9.10.
And
9.8. Now those are the individual contributions to the portfolio. To get the total portfolio return, you need to add that to that. So I've run out of space. But if you take 4.5 to 11.9, you get 16.4 for the year for that portfolio. You add them up. That's 17.4. 17.4 plus 16.4 plus 16.3 15.3 14.2 and finally 15.5. Can't get, I'm right at the bottom here. Your total return for this, that's the individuals per year for each one of those years. That's your portfolio return, which is made up of adding up the contribution of property A and the property B together per annum. So the question first reads, calculate the expected portfolio return percentage for each of the 6 years. That's what each of the 6 years represents. Then part B of the question, calculate the expected average percentage of the portfolio returns over the 6-year period. All you simply do is you add those up together. You add up all of the 6 years together. You get 17.4 plus 16.4, 16.3 plus 15.3 plus 14.2 plus 15.5 gives you 95.10. 95.10. To divide that by 6 to get the average per year, and the answer is 15.85. So your average return per year for this portfolio was 15.85%. So to recap, work out each property's contribution per annum, which are the 4.8, 4.5, etc., and it's 12.6, 11.9. That's per annum contribution. When you add the one to the other, you get the total per year for the portfolio, which is the bottom column here. And then your second question was calculate the expected average percentage of the portfolio over the 6 years. Simply divide it by 6. Add them up, divide by 6. Straightforward as that. We're just not working with monetary rand values, we are working with percentages in this question. Okay? Did you get that, Lloyd?
Made a mistake.
Ish. Made a mistake.
Yeah, the assignment.
Okay. You recognize the question. You recognize that question immediately.
But I did a total calc of that plus they'll give you that instead of going there.
No, but it should be the same.
Yeah, it is. But I divided by 2 instead of 6.
Oh, it's by 6 years. The answer is divided by 6 because it's 4.
Because the question is saying average, then I thought.
But it's continue with the question. It says average percentage of the portfolio return over the 6-year period. I tried to make it as clear on the question.
The first part is correct.
Okay, you got that.
95.
Which is your 12 or your 15 marks. So you only lost the 3 marks then.
That's cool.
Okay. The next part, the next calculation question dealt with the probability of outcomes. Yeah, we had. Let me try and use less space so I don't get. I'm used to using a wider whiteboard, and now the flip chart is considerably narrower. The next question I want to cover is Mr. Joe Soap, who is considering purchasing an income-producing property. The building will cost 15 million to be paid immediately. There's a salvage value of 1.5 million at the end of its useful life of 10 years. So if I show you a timeline just to give you an idea, it's a 10-year period. The cost up front, the initial outflow, or the initial is 15 million. Negative 15 million. We say at the end he salvages 1.5 million. Cost of capital is 9%. And we're expecting to get 10 years of cash flows from this property. We have got given to us the probability of outcomes as follows. When you're looking at the probabilities, they will always add up to, if you're using decimals, they add up to 1. Or if that could also read 10%, 30%, 50%, 10%. That is of the time. Whilst, and then we are saying the cash flows would be $1 million. No, so no. 1,200,000. 1,400,000. And 1,600,000. That's what you're given. The question is, by applying the probability of outcome, calculate the expected cash flow per year. What is the expected cash flow per year? By applying this to that, right? Per year, for each of the 10 years. So 10% of $1 million gives you 100,000. You're 100,000. 30% of 1,200,000 gives you 360. Is this what you did, Lloyd? Okay. 50% of 1.4 million gives you 700,000. And finally, 10% again of 1.6 million gives you 160,000. So if you add up the cash flows, you get 1,320,000. That answers the first part of the question, which reads as follows: by applying the probability of outcomes, calculate the expected cash flow per year. Expected cash flow per year. All right? It excludes. Sorry? No, that
because it's 350.
Possible, yeah. 555, yeah. What is the expected net present value? Now you're going to work out the net present value of all of those numbers.
5.895.
Oh,
Done.
done. To work out, this is basically answering just the one question. That is your annual cash flow, excluding the outflow here, and excluding what's available at the end, the salvage value. So those cash flows was for the cash flows for the 10 years. Okay, I believe you, Lloyd. I believe you. Now, to determine the net present value, which is your next part of the question, you need to say the following. 3 columns, year, and present value. So you've got the years, naught, because we had the outflow at point naught on the timeline, which I showed you on the previous page. You had an outflow of 15 million, which is negative, so I'll put it in brackets. And the present value of that remains 15 million because it's already at point 0 on the timeline. From years 1 to 10, we had a regular income flow of 1,320,000, which we've determined on the previous page. We need to work out the present value of that annuity. The 10-year cash flow We'll do it as follows. One per year. We're 1,320,000 plus minus payment. 10 shift N at the interest rate we were working with is 9%. And your present value of that is 8471308. Right? Then we had the salvage value to contend with, which was also at year 10, right at the end. It was 1,500,000 that we got back, so we salvaged that. And by discounting that for 10 years at 9%, we got to a figure of 633,616.
0.21.
Yeah, don't worry about, I haven't used cents on this calculation, so I'm leaving the cents out. Your net present value is your sum of these three added together. That gives you 5,895. It's still in the red. It's a negative figure. 5,895,076. So after 10 years, you still haven't recouped your outflow, your initial cost of 15 million. The third part of the question is, should the investor purchase this building? Justify your answer. For that, I would accept should not purchase it because he still hasn't broken even after 10 years. Did you not understand it as such?
No, because I
put it down as a positive.
Yeah.
Okay, it makes a difference. Big difference.
Okay, cool.
So we've just taken that cash flow for this
It's a negative
property. It's still negative after 10 years, so don't touch it. That's what basically we are saying. Those are the final two calculations I wanted to cover. Earlier this morning we covered the chapters that you will find the theory on. So all I've got now is any questions from you, Lloyd, regarding finalizing what's the assignment is due. I don't know off the top of my head when is the assignment 4 due. That's tomorrow, Thursday.
I already submitted it.
You've done it, great.
But
By the time that the rest of the countries gets to see this video, they will have submitted the assignment, they will have the marks, and we will just be waiting for the assessment. Half calculations, time value of money calculations, half theory. Okay?
Cool.
Excellent. Thanks very much. Cheers. That's it. Thank you.